Hello everyone, myself Mohammed Kaif, studying in Sri Venkateswara College of Engineering from CSEI department. So today I'm going to explain about the topic Introduction to Breadth First Search. So breadth first search it is a graph traversal algorithm used to explore all the vertices of a graph in a symmetric manner. It starts from the root node and explores all the neighboring nodes at the current depth prior to moving to the nodes at the next depth level. So, breadth first search is known as also VFS. So, moving on to the definition and the purpose of breadth first search. So, the first one is the graph traversal, and second one is the shortest path, and third one is the minimum spanning tree. Under the graph traversal, VFS significantly explores all the vertices of a graph to find the specific nodes or paths. And the second one is the shortest path. It is often used to find the shortest path between two vertices in an unweighted graph. Third one is the BFA, minimum spanning tree. Under this, BFS can be used to find the minimum spanning tree of the connected. And the BFS symmetrically explores all the vertices of a graph to find the specific nodes or the paths. And how the breadth first search works. So basically, it works on the queue based and visited nodes and at the last level order traversal. BFS uses a queue data structure to keep track of all the vertices that need to be explored. And second one is it maintains a record of visited nodes to prevent the revisiting the same nodes and to avoid the infinite loops, which it creates the error for the next nodes. And the third one is the level order traversal. The nodes are explored level by level, making BFS suitable for the finding shortest path, and it maintains a record of visited nodes to prevent the revisiting of the same loop and further repeating of the loops that can be further repeated for the errors. Okay. And the next one is the pseudocode for the bit first search algorithm. As you can see, the queue is known as the queue is equal to new queue, and next source of node that has visited that will be saved as queue NQ. While queue is not empty, and the queue dot DQ. For each neighboring you visit the loop, it will be saving as the U or U of V2. And the pseudocode for the breadth first search would start by initializing a queue of an array to keep track of visiting nodes, and the NQ and DQ. Add the starting node to the queue, then DQ a node visiting its neighbor and NQ them. And third one is the termination. The process of termination continues until the queue is empty and all nodes are visited. Initializing, NQ, DQ, and the termination are the three the steps of pseudocode for the breadth first search. And the third one is the time and space complexity of breadth first search. And for the first one, the time complexity is of BFS is V plus E, where V is the number of vertices and E is the number of edges. And the space complexity, BFS has a space complexity of O of V, as it only requires space for the visited nodes and the queue. And the next one is the applications of the breadth first search. First one is the shortest path and the minimum spanning tree. Under this, we use to finding the shortest path and the minimum spanning tree in an unweighted graph. Second one is the network broadcast, efficiently finding all the nodes reachable from a source node in a network. Third one is the web crawling, utilized by the search engines to index web pages and crawling from the shortest root page. The three applications of BFS are shortest path, minimum spanning tree, network broadcast, and web crawling. And the advantages of disadvantages of BFS are it guarantees to find the shortest path in an unweighted graph, and it also is suitable for the P2P media streaming and copy detection. And the disadvantages are not efficient for the weighted graphs or large scale networks. And the second one is it uses most memory space compared to depth first search. in and worst case scenarios. And the conclusion and the keys of takeaways are effective graph exploration and resourceful algorithm. BFS is a valuable tool for symmetrically visiting and exploring all the vertices in a graph. And the second one is the resourceful algorithm. It has various practical applications in different fields like computer networking, data mining, and bioinformatics. And the effectiveness breadth first search is a versatile algorithm with diverse application and balanced time spans based complexity. And in the critical analysis, it is essential to access the suitable of BFS based on the specific graph structures and the search requirements. So thank you for watching my video. Please share and subscribe. Thank you.